Methods of proofs and disproofs. The process of establishing that the condition is true by using the rules or laws of logic. The process of establishing a proportion is false and constitutes the disproof. If the condition is true, then we'll prove. That is then establishing proposition is false, that is disproof. Direct proof. This is the first method. The direct method of proving of conditional P to Q has the following lines. Hypothesis. First, assume that P is true. Then, analysis. Starting with the hypothesis and employing the rules or laws of logic and other known facts. Then, infer that Q is true. Then, the conclusion is if P, then Q is true. Give a direct proof of the statement. The square of an odd number is an odd integer. So the conditional is to be proved is if n is an odd number, then n square is an odd number. The square of an odd number is an odd integer. So we have if n is an odd number, then n square is an odd number. Hypothesis. Let us consider assuming that n is an odd number. So n equals to 2k plus 1 for all k belongs to integers. Then for n square, 2k plus 1 whole square, that is equals to 4k square plus 4k plus 1 is not divisible by 2. N square is not divisible by 2. Conclusion: n square is an odd number or integer. Prove that for all integers k and l, if k and l are both odd, then k plus l is even and kl is odd. Yes. Hypothesis assume that k and l are odd integers. That is k equals to 2m plus 1, then l equals to 2n plus 1. For every m comma n belongs to integer. K plus l equals to 2m plus 1 plus 2n plus 1. That is addition of k plus l. Then we will have 2m plus n plus 1, which is divisible by 2. KL equals to 2m plus 1 into 2n plus 1, 4mn plus 2 into m plus n plus 1 is not divisible by 2 because plus 1 is there. Conclusion: k plus l is an even integer and kl is an odd integer. Then, next comes the indirect proof. The method of proving a condition by using the direct proof to its contrapositive statement is called indirect proof. Let n be an integer. Prove that if n square is odd, then n is odd. This is an ulta thing. P is they have given as n square is odd, then n is odd. This is the statement which they have given. If P, then Q. Let us consider the contrapositive of that. What is contrapositive? If not Q, then if not P. So not Q is n is not an odd number. Then we will have n equals to 2k. That is n square equals to 2k whole square. Is divisible by 2. Then n square is not an odd integer. The contrapositive is true, hence P to Q is true. Give an indirect proof of the statement. Indirect. The product of two even integers, is an even integer. The product of two even integer. So if a and b are even integers, then ab is an even integer. So let us have this p equals to a and b are even integer, and q is ab is an even integer. So we have to prove that indirect proof contrapositive. That is not q, not p. Not q is ab is not an even integer, which means ab is an odd integer. ab is not divisible by 2. Then a is not divisible by 2. and b is not divisible by 2. So if a is an even integer, a is not an even integer, b is not an even integer. Conclusion: a and b are not an even integer. So the contrapositive is true. Then hence the if p then q is true. Provide an indirect proof of the following for all positive real number x and y. If the product xy exceeds 25, then x is greater than 5 or y is greater than 5. So the given condition P, Q or R. P is if xy greater than 25, Q is x greater than 5, R is y greater than 5. If P then Q, that is the contrapositive of this is not Q and not R, then not P. Assume that x is less than or equal to 5 and y is less than or equal to 5. Then we have xy is less than or equal to 25. Conclusion: xy is less than or equal to 25. Thus the contrapositive is true. So P, if P then Q or R is proved using indirect proof. For each of the following statement, provide an indirect proof by starting and proving the contrapositive of the given statement. For all integer k and l, if kl is odd, then both k and l are odd. Then we have to take contrapositive. Both k and l are not odd means which means k and l are even. And then kl is also even. We are taking it as like this. K and L are even. Assume that K and L are even. Hypothesis. That is K equals to 2m, L equals to 2n. Then KL equals to 2m into 2n. That is 4mn. Which is divisible by 2. Conclusion: KL is even. Thus the contrapositive is true. Hence the given statement is true. The contrapositive statement is for all integers k and l, if one of the k and l is odd and the other even, then k plus l is odd. The contrapositive statement is yes. We have to take like this. For the second one, for all integers k and l, if k plus l is even, then k and l both are even or odd. They have given it as even or odd. Contrapositive statement for this is for all integers k and l, if one of k and l is odd, if one of k and l is odd and the other is even, then k plus l is odd. So here the statement which they have given is k plus l is even. If k plus l is even, then k and l are both even or odd, or both even or both odd. Okay, then for all integers k and l, if one of k and l is odd and the other even, then k plus l is odd. So hypothesis is taken. Let us assume that if k is odd, then l is even. 2m plus 1 2n. Then k plus l will be 2m plus 2n plus 1. 2 of m plus n plus 1, which is not divisible by 2. Then k plus l is odd. The contrapositive is true. The given statement is also true. Then let m and n be the integers. Prove that n square equals to m square if and only if m equals to n and m equals to minus n. So consider the propositions P. This is for the indirect proof. Prove that if m equals to n or m equals to minus n, then n square equals to m square. We have to take that as contrapositive. N square equals to m square, then q equals to m equals to n, m equals to minus n. To prove that is equivalent to q or r. If and only if means we will be using this. Hypothesis assume that q or r is true. Then m equals to n or m equals to minus n, so that m square equals to n square. Thus q r r 2p is true. Assume that not q or r is true. Not q and not r is true. Q is false and r is false. M is not equal to n and m is not equal to minus n. Therefore, m square is not equal to n square. Thus, not of q or r is tends to my not p is true. Hence, we will consider if p then q or r is true. Then the conclusion is p is equivalent to this if and only if q or r is true.